if there is one good thing that came from the pandemic, then it's the fact that my extended family finally understands what I do. Because I'm a statistician and people like me were on TV and I was so proud. My name is Isabella Deutsch, I'm a PhD student, and today I want to talk about the fundamentals of statistics and why they matter if you want to fall in love. Numbers are objective. If we look at number 4, for example, there is no room for interpretation. Well, for the know-it-alls in the audience, in base 10, of course. So numbers are objective. But if the pandemic taught us another thing, then it's the fact that statistics, however, is not. I brought an issue of The Guardian from the 10th of April 2020 with me. And the headline reads, "Hundreds dying of virus in care homes, not counted in official data." So while this is really quite a sad headline, it drives home the fact that how we analyze data is far from straightforward. And it's really up to us statisticians to decide how to do that. Put it differently, statistics is about answering tricky, tough questions, like how many people are there on Earth, maybe how tall are adults in Edinburgh, or how many people sadly died in the pandemic. Often finding the exact answer to those questions is difficult, and in other times it's downright impossible. So it's up to us statisticians to come up with a best educated guess to answer these questions. This best educated guess will often have some uncertainty associated with that, but we're okay with that because we have something to help us, and that is data. Now, how we use this data to get to our best educated guess is, again, not straightforward. And it's, again, up to us statisticians to discuss that. In statistics, there are 2 big schools of thought that differ in how they use this data. And that is what we're going to talk about now. Those 2 schools of thought are called frequentist and Bayesian statistics. Frequentist statistics comes from the word frequency. And the other one, Bayesian statistics, is named after Reverend Thomas Bayes, who actually studied in Edinburgh and also gave his name to this building, the Bayes Centre. So let's start with frequentist statistics, a great straightforward way to do statistics, really the no-nonsense of stats. If you want to get a best educated guess, you're going to take an average. So if I want to answer the question, how tall are adults in Edinburgh, I'm going to take a sample. So I could ask some of you, maybe not the front row, because they're more likely to be smaller or cheeky. And I can ask you for your height and calculate an average. Bam, great best educated guess. And it's a really straightforward way of doing statistics, really often used. It is actually so popular that when I started studying statistics in my undergrad, I did not know what frequentist statistics was because I thought that was just statistics. That's how popular it was. So you can imagine my surprise when I come to the University of Oxford for my master's and this whole world of statistics opens up in front of me. It really was like stepping through the wardrobe into Narnia. But instead of an evil white witch, there were just a lot of difficult equations to solve. So this brings us to Bayesian statistics. When frequentist statistics is data, Bayesian statistics is data and prior knowledge. Because sometimes there are things that are so fundamental to the world that we can actually use it in our analysis in addition to data. You might say more than data to statistics, and quite rightly so, you might be skeptical. But let me tell you, we are all using Bayesian statistics quite successfully on a daily basis. And the example we're going to talk now, if you want to fall in love. Let's say you are currently single and you would like not to be. And you've been on a couple of dates in your life so far. This means, unfortunately, all the dates so far have not resulted in a relationship lasting today. So if you are a frequentist statistician, you have collected some data. And if you now want to calculate the probability of finding love on your very next date, well, you're frequentist, you're going to take an average. The average of 0 is unfortunately 0. So, sorry, 0% success rate. You are a lost cause and you might as well become a nun. But don't worry, not all hope is lost. You have collected the very same data, still not very successful, but still. Now for the Bayesian approach, we have something that is so fundamental to the world that we can use it in our analysis, and that is that love is out there. So if you are a Bayesian statistician looking to fall in love, I've got good news for you, because your probability of falling in love is 2%. Because finding the right person and falling in love with them is still quite difficult. So what does this all mean for our statistics? Frequentist statistics, really great way. Sometimes we have problems that really need a Bayesian approach. What makes us really rest easy at night is that if we have lots and lots of data, they both give the same answer anyway. Me personally, for my research here in Edinburgh, I have chosen Bayesian statistics. And throughout my research, I have really fallen in love with it. And that is why I want to end my time here with you with a love poem that I wrote for Bayesian statistics. Amidst the data's wondrous sea lies a method quite dear to me. A way to weave a data story true and unlock insights so brand new. Of all the methods in statistics, my heart belongs to Bayesian mystics. With prior beliefs and data collected, our models are ever so quickly perfected. The power of Bayesian statistics brings new light to old heuristics. Assumptions, estimation, and decision, all made possible with Bayesian precision. Inference comes with great ease, and it's straightforward to make hypotheses. From parameter estimation to model fit, Bayesian stats is just a hit. Bayes' theorem as our guiding light. Our journey in statistics is gonna be bright. Its beauty, like a work of art, forever holds a place in my heart. Thank you very much.